When you collect data that fall into groups, like preferred streaming service, political affiliation, or type of pets, the first step is to count how many observations fall into each category. Those counts form the backbone of both tables and graphs for categorical data. In this video, we'll learn how to build simple frequency tables, translate them into proportions or percentages, and organize two categorical variables together in a two-way table. Along the way, we'll see when different visual summaries make sense and preview bar and pie charts, which are covered in a later video. A frequency table is a basic but powerful tool for summarizing a categorical variable. It lists each distinct category and records how many observations fall into that category. By organizing raw data into counts, a frequency table provides an immediate snapshot of how the data are distributed across categories, making patterns and imbalances easy to see. A typical frequency table has two columns, one for the category labels and one for their frequencies, or counts. Constructing a frequency table involves identifying all possible categories and tallying the number of observations in each. This process is often the first step in data analysis because it reduces a potentially large and messy data set into a clear and interpretable summary. While frequency tables report absolute counts, these counts can be misleading when sample sizes differ. For example, a category with 50 observations may seem large, but its importance depends on whether the total sample size is 100 or 1,000. To address this, we often compute a relative frequencies. A relative frequency expresses the count for each category as a proportion of the total number of observations. When a column of relative frequencies or percentages is added to a frequency table, the result is called a relative frequency table. Relative frequencies are calculated by dividing each category's count by the total sample size. Because they represent proportions of the whole, relative frequencies always sum to 1 or 100% when expressed as percentages. Relative frequency tables are especially useful for comparing distributions across different samples or populations. By focusing on proportions rather than raw counts, they allow meaningful comparisons even when the underlying sample sizes are not the same. For this reason, relative frequencies are commonly used in reports, visualizations, and summaries intended for broad audiences. In practice, frequency and relative frequency tables often serve as the foundation for graphical displays such as bar charts and pie charts, providing a clear numerical summary that complements visual representations of categorical data. Imagine you survey 30 patients at a local clinic about the primary symptom that brought them in. You record 4 categories: a headache, back pain, fatigue, and nausea. We can organize the responses in a simple table of counts and proportions. The table lists the 4 categories in alphabetical order with their counts and relative frequencies. For instance, if 8 of the 30 patients reported headache, the relative frequency of headache is 8 divided by 30, which is approximately equal to 0.27. The bar chart gives a visual sense of the same information. Each bar's height corresponds to a category's frequency, and the bars are separated to emphasize that the categories have no inherent order. In practice, you might reorder the bars to make the graph easier to read, perhaps putting the largest category first. Sometimes you want to highlight the few categories that account for most of the observations. Pareto chart is a bar chart arranged in descending order of frequency and often paired with a cumulative percentage line. It helps you identify the vital few and trivial many in quality control and business applications. Pareto charts are useful when there are many categories, and you want to focus attention on the most common causes or responses. When data include 2 categorical variables, a natural question is whether and how those variables are related. A two-way table, also called a contingency table, provides a clear way to summarize and explore this relationship. Rather than listing categories separately, a contingency table displays the counts for every combination of categories across the two variables. In a contingency table, one categorical variable defines the rows and the other defines the columns. Each cell in the table shows how many observations fall into the corresponding pair of categories. The table also often includes row totals, column totals, and a grand total, which help place the individual cell counts in context. Contingency tables are especially useful for examining associations between variables. By comparing counts or proportions across rows or columns, you can look for patterns such as whether certain categories tend to occur together more often than would be expected by chance. For example, you might ask whether voting preference differs by age group, or whether product satisfaction varies by subscription type. Contingency tables form the foundation for formal statistical analysis of categorical data. In later videos, these tables will provide the structure for chi-square tests of independence, which assess whether the observed association between two categorical variables is stronger than would be expected from random variation alone. Even before formal testing, however, contingency tables offer a powerful descriptive tool for uncovering relationships in categorical data. Data interpretation, contingency tables are often converted to conditional distributions by computing row or column percentages. Row percentages answer questions like, given this row category, how are observations distributed across the columns? Column percentages reverse the conditioning. Choosing which percentages to compute depends on the research question and which variable is considered explanatory versus response. Suppose we collect data on the same symptom question in the last example, but also record each patient's age group, under 30, 30 to 50, or over 50. We can summarize the joint distribution in a two-way table. Each cell in the table shows the number of patients who fall into the corresponding combination of age group and symptom. We can also compute row or column relative frequencies to see percentages within each group. For example, dividing each row by its total gives the distribution of symptoms within each age group. Contingency tables allow us to see whether symptom patterns differ across age groups and serve as input for clustered or stacked bar charts. Because categorical variables can have different numbers of levels and sample sizes can vary, relative frequencies are essential for fair comparisons. Reporting only counts can be misleading. 20 supporters of a movie genre in a survey of 50 people represent a large fraction, while 20 supporters in a survey of 500 people represent a much smaller fraction. Percentages standardize the scale. When displaying percentages, make sure they add to 100%. In a pie chart, each slice represents a category's percentage of the whole. Pie charts are useful for showing how the total is divided among categories, but they become cluttered with too many slices. Bar charts are more flexible. You can reorder the bars, show counts or percentages, and compare multiple groups using side-by-side or stacked bars.